CSP, concentrated or PVs, different lands, different frameworks. And we added another component to that work, which is looking into the economical side of it. And our colleague Ucheng in the morning was talking about the observations where it doesn't link any kind of economical value, but in this paper here, we were able to see, like, the amount of the solar radiation and how much you would suffer in terms of financial losses if you were, like, to establish different kind of solar power plants in locations which are impacted one way or another by dust particles or dust storms. So we put it in a framework where you are able to calculate how much economical losses can happen as a consequence of that. And that was the hospital, the framework. This is the rendering of the project done by Lord Norman Foster, who is doing that design. And this is the land that we are establishing the solar farm for that hospital. And we created around 37 different kind of options for that solar power plant in order to give them different kind of investment plans, how much they need to spend in terms of a solar farm for the production. And this is a snapshot of the economical model where you have a lot of inputs which take into account how many days you have dust, the amount of solar radiation, the GHI or DNI, some terms which might be used for people who are more into the solar business. And these are my concluding remarks. So I think through this very quick skim of some different kind of topics, we are able to see how much dust is having an impact across different kind of sectors. And in order to have an improved dust forecast, it's going to only come from a new prototype of high resolution numerical and dynamical model. And that by itself will not work if you don't have accurate mapping and monitoring of dust sources and application of what is known about their mineral, chemical, biological content, soil texture, and size distribution. Third, greater spatial coverage of dust-related observations from ground and space is quite important to validate and optimize model simulations. So this is what needs to be done by the scientific community in order to achieve this kind of improved dust forecast. What do we need to do in order to do that? The beginning of this coalition is a very good starting point. It's at least getting a lot of entities, a lot of organizations to be talking with each other. We need to be promoting this across different nations, across different countries, where they can see the impact of these dust storms on their specific sectors. You name it. Somebody might be affected in the health sector, somebody might be affected in the marine environment, and as such. So it needs to show the impact across different sectors so that you have more and bigger involvement. Identify observations, modeling, and applications, information gaps. We need to figure out where are the information gap, where is the part we are losing in order to deliver our message in the right way. With appropriate user groups, identify realistic dust forecast and simulation-related products with optimum minimum scales of achievement. And of course, this is not going to happen unless we have appropriate research and development scheme or framework. Thank you so much for your attention, and I'll be happy to take questions if any. Yeah. Thank you.
Thank you, Professor Hasim. You cover a very wide-ranging issues from the science to the origin, to the impact, and now economic impact. Thank you very much for this enlightening talk. Would you like to take up one or two questions now, or after all the speakers? Yeah, please. Okay.
Thank you. I think it is very good presentation, and also it's comprehensive.
Appreciate it.
Yeah, my question, what's the message to deliver to us from out of this presentation? Thank you.
Thank you. I think the message is to really understand that with the changing climate, or with the global climate and the environmental change that we are observing, we need to start thinking about dust storms from a holistic point of view, and to realize or to know that this is not something that is not going to affect us dramatically, in the coming few years. Like the 1.5 degree report that came last year was talking about like, a framework that needs to be enhanced or taken care of like before 2030, because we are observing a changing climate on a very, very rapid pace. Dust storms are gonna increase in terms of magnitude, in terms of frequency. We are going to observe more and more land degradation. You are going to observe more and more losses of agriculture. And if this is not taken in a very serious way, like I don't know how we are going to be able to survive in a short term. So my take-home message would be each one of us in whatever they are doing, either they are affiliated with a UN entity or an academic or any kind of stakeholder, they have a message to deliver to their home institution where everybody needs to come together in order to really address this phenomena at a scale or in a way which is cross-sectorial, like to see the benefit for everybody, like, and nobody is like, to say like, it's not my real problem. I really don't need to worry about that. No, there need to be a global mind about such an environmental issue, because in my opinion, like, it's one of the most drastic ones.
Yes. In the interest of time, please be brief. That's my request. Thank you.
Okay, thank you very much. My name is Mohammed Balal from Sudan. I would like to thank Hashim for this very, very interesting presentation. I have seen in one of your slides in Arabic, you said that greening Egypt or creating agricultural land will affect other countries positively. So could you please elaborate in this one?
Can you say this word again, please? I couldn't hear.
Yeah, I've seen in one of the Arabic slides.
Yeah.
You said that greening Egypt or increasing agriculture. Yeah. This is one question. And the other question is there any way of mitigating sandstorms or alleviating the negative impacts of it? Thank you very much.
Thank you so much. The point that you are referring to was in reply to the impact of dust on hurricane formation. So when I said about like the Wall Street Journal report, which came out saying that the U.S. lost close to $200 billion because of the hurricane season, there was a lot of there is a paper that came in Science late 2018, which is showing that if you are working, that's a paper published in Science, and it is saying that if the Saharan desert is to be cultivated or is to be covered by solar panels, it will reduce the climate footprint by at least one degree Celsius. So it can really contribute to alleviating this kind of problem. So that's what I was referring to. The cultivation or greening areas in North Africa can really help the U.S. in mitigation or in minimizing the impact of dust on hurricane formation. Yeah, that's what it said.
Thank you, Professor.
Thank you so much.
We have just 1 hour before the high-level meeting. Yeah. The next speaker is Marijona Solomon from UNCCD SPI.
Before presentation starts, I would like to say hello to all of you and give some few technical information. This presentation has been done in close cooperation with UNCCD Secretariat and the consultant who was being engaged in this research. That wasn't me, but I am going to present this research in the best way I can because consultant wasn't able to participate in this important event. So I'm just waiting to start final page. Yes, I'm doing that, but yeah.
Yeah, please.
Okay, here we are. So here on the first slide, I'm going to introduce some definitions that are important to understand what has been done under this work. Sand and dust storm source is defined as a bare topsoil surface accessible to the wind erosion or any surface capable to emit soil particles in favorable wind conditions. Areas that include SDS sources have fine soil texture and bare or sparsely vegetated areas which can experience not frozen and low soil moisture condition. Capacity of soil surface to emit soil particles under these favorable wind conditions is named here as the SDS source intensity. We consider here that if SDS source exists, it has some values of SDS source intensity. If SDS source intensity is 0, source doesn't exist. So SDS sources stay inactive if there is no wind strong enough to provoke emission particles from the surface. SDS source activity depends on the frequency of high wind conditions. So this intensity has been changed during the year. In some periods, they have this source intensity 0, that meaning they doesn't exist. And in some period, they can reach high intensity value. So we can divide those sources in two groups, permanent and dynamical ones. Permanent are the ones that have capacity to emit soil particles, meaning to contribute to SDS formation during the whole year, and dynamical ones are the sources that change their intensity during the year and appear only seasonally or occasionally. Drivers that impact these sources intensity are listed here. So you can see climate and weather conditions, surface conditions, and of course human activities. And all of them are interlinked. Climate is distinguished from the weather because climate is one of the main drivers that cause formation of permanent SDS sources in desert areas. Extreme aridity followed by the periods with high winds left desert areas with removal of vegetation or even water bodies and long-term exposure to erosion, which consequently leads to the formation of SDS sources. Weather conditions are distinguished because extreme weather deviates from usual climate behavior. This driver considers impact of extreme events on SDS sources intensity, such as drought, heat waves, storms, etc. When it comes to surface condition, land cover, soil properties are among the most important one, together with soil temperature and soil moisture. Human activities has become very important degradation drivers that impact these sources very intensively in the last decades. Okay, so we are coming here to the anthropogenic sources because of the increasing importance of these human activities on the SDS activity and assessment that large part of the total atmospheric dust transport is caused by human activities. 10 years ago, assessment was 25% from the total amount. It is important to introduce the terminology anthropogenic sources, which is defined as the one when human activities are predominating driver for SDS sources intensity. But we can recognize what are possible human impacts on the formation of such sources and divide them in direct and indirect impacts. Direct impacts consider change of land cover, like removal of natural vegetation, deforestation, and disturbance of topsoil structure related to the agricultural activities, unsustainable land management practices, etc. Indirect human impacts that comes from climate can amplify droughts, heat waves, and even increase permanently aridity of the area, intensify storms, and so on. So SDS events. There are some examples of SDS and airborne dust transport that originates from SDS sources. We distinguish global, regional, and local transport depends on the distance from the sources. Duration of SDS is directly related to the spatial scale of the affected areas. Here, we can represent time and space scales of different SDS and consequently produced high-altitude dust transport processes in the upper atmosphere. So duration and the distance from the SDS source is already mentioned. Longer duration means longer distance of impact. Here on this diagram, you can see that there is a large spectrum of scale of SDS events, but also a large spectrum of scales of SDS productivity areas. It is important to have in mind that SDS productive areas can consist from cluster of SDS sources on smaller scales. So local transport can last for a few minutes, while this global transport can have that, let's say, impact that is lasting for the centuries. Now I'm going to present the mapping methodology for SDS source mapping that can be divided in two groups. First one is SDS source mapping based on SDS observations, using satellite data and or ground data that are available on visibility. Advantage of this approach is that it can recognize most active SDS sources and major global and regional sources. But because it relies on SDS observations, which are not consistent in space and time, this approach underestimates SDS sources that are not frequently active. Also, precise placement of source areas, especially small-scale hotspots, cannot be well represented. Second type of the methodology is SDS source mapping from data on surface conditions. This methodology uses soil and surface data and can produce high-resolution SDS source patterns with recognition of SDS source hotspots within SDS productive area. But this approach requires complex combination of input data sets and depends on the quality on soil data. Applying different methodology for SDS source mapping will give results that are in certain agreement in patterns as expected, but real meaning of the results is different. Mapping from SDS occurrence will give map of SDS activity and not exactly placement of source areas, but it assumed maximum are in the regions and it gives results on the lower resolution. Maps derived from the methodology that we are going to see later on that is chosen for this work, SDS source mapping data from the data on surface condition provides information on SDS source intensity and not activity, which represents real source distribution. It's possible to have it on high resolution, but information on frequency are not included. Best choice for the risk assessment and the impact of sand and dust storm would need combined approach that relies on SDS source intensity map and atmospheric data as well. So now we are coming to the choice of methodology for this research. We considered extensive analysis of pros and cons of different methodologies. For the purpose of SDS source mapping is chosen, as already mentioned, SDS source mapping from the data on surface condition. Frequent question is why wind data are not included, but they are actually of secondary importance because in the surface has some SDS source activities. Strong SDS will happen for sure in some areas, more frequently in some less, but this SDS source area will be activated. For example, SDS source near populated area are not frequently active, so be once per year or in several years, but they can affect 1 million people. So even these sources have much lower activity but high intensity and damage much higher than very active sources in desert areas. So real risk assessment from SDS requires much complex approach than just inclusion data about wind. Also, as mentioned before, for global mapping, no suitable wind datasets exists. This is just short example and simple one as a scheme that explains main difference from these two approaches in mapping. One on the left is the example of land surface area with distinguished hotspot sources. High wind is more frequent over some sources and over some less. Sources emit dust plumes downwind. On the upper picture is presented map that can be derived from the example satellite data on the SDS occurrence. On the lower picture is presented map that can be derived from the surface data. Since our main goal was to assess SDS sources, we can see why our choice on the methodology is the second one. Cluster of data. So data set needed for the mapping for these purposes of SDS sources using surface data are listed here. All of them are on this slide. Soil characteristic represented a susceptibility of soil surface particles to the wind erosion. They include most important, of course, soil texture information, which is important for emission and, of course, formation of SDS. Land cover data include what kind of land cover we have. Do we have any forest, any kind of, let's say, water bodies, etc., or there is ice cover, or even what kind of vegetation cover do we have there. Soil condition are data variable soil properties like soil moisture and temperature. And existence of implementing of natural data can improve, of course, resolution and accuracy of this map because If possible, it would be the best choice to have national SDS source map. Now we are coming to represent the global sand and dust storm base map, how it has been created. The reason why only these 4 months are selected for the purpose of global map is to save time on computing. Assuming the cycle of SDS source intensity change during the year will be well represented at global level using data for these months. Here, on this slide, there are more detail what is considered is SDS mapping. Top priority is to map areas with sufficient fine soil texture and free surfaces. SDS productive soil texture is already discussed, is the one that we have sufficient clay and silt content. Silt is most efficient to contribute to SDS, and clay and sand less when it comes to the soil texture. Major concerns are that soil texture information for the whole globe is of low quality because there were not enough measurement in some areas. Some countries do not have soil map at all that are available online. So it has to be, that data cannot be included in this global data set. It means that percentage of finer and coarser fractions is not well represented, and mapping is very sensitive to this parameter. Another challenge was former lake beds that are dried relatively recently because climate change impact and water scarcity, they didn't have any soil data. I would need some water now, a little bit. We are running out of the time, so I will go straight to the results, but all details will be listed in the report that has been published on the UNCCD website, and everything can be found there regarding methodology that has been chosen for this kind of research. Let me go. Okay, so I'm going just to find our results. Okay, here we are. Soil temperature data are also derived from ACMWF for each month, for each day for the 5 years, for 2014 to 2018, and maximum value for each month was retrieved as input for mapping presented in the picture. Using maximum soil temperature instead of average can represent maximum possible frozen condition for each grid point that may happen in present and probably near future. To define bare land fraction that used MODIS data, MODIS heavy were retrieved for 4 months for the same period, and using minimum positive value instead of average can represent maximum positive bare land fraction for each grid point that may happen in present and probably near future climate. If heavy is positive and less to equal or equal to 0.1, bare land fraction is 100%. When it comes to bare land fraction, too, MODIS land cover data are used to support bare land fraction mapping from heavy data because of shallow water, dark soil, and surfaces of mixed color that have small heavy, but actually cannot be SDS productive. Okay, on the monthly level, here are some results. Monthly maps of SDS sources that represent SDS sources intensity, meaning capacity of the soil surfaces to produce SDS, have in mind that weakest small intensity sources probably do not produce SDS, but rather blowing dust event. Many different versions of SDS source maps can be derived from these results. Examples are on the following slides. This is map of annual sources on the global level that have some intensity during the whole year, permanent SDS sources, and corresponds to the previously mentioned map derived from the different SDS study. Major parts are located, as you can see, in the dust belt, like Australia, etc. Maximum and minimum are values for SDS sources intensity derived from the monthly data. Comparing these two maps, we can see how large is the variability of SDS source intensity related to the change of weather condition and consequently the change of bare land fraction. Dynamical sources. Here is presented difference between maximum and minimum values of SDS sources intensity. So this map shows dynamical sources that change their intensity all over the year. On this image, in the overview image, We can see clearly permanent and dynamical sources, so also sources with high maximum intensity are highlighted. So now I'm going to stop to talk because I'm over the time. Am I? Yeah? But I want to say that this global map is only served for the countries to use it the same as for the LD and TSP process, and to use for the further research and have any kind of overview about sand and dust storm in their country and their region. So for any questions or any comments, you can address it right now, or maybe you can write it down so we can forward it to the author who done this huge work. I didn't expect this large presentation, but anyway, I hope that I give you sufficient information on this. Thank you very much.
Yeah. Thank you, Marijona. For any query, I think after the session, those who have some specific query, they can reach you. In the interest of time, now I would like to invite Professor Kim from University of Seoul